Last summer, astronomers noticed something off, and it was, wait, that's not supposed to happen off. They spotted a weird mix of signals in their data. After double-checking, triple-checking, and probably staring at the screen in silence for a while, they realized it was something they'd never seen before. They may have just caught the first ever superkilonova. You've probably heard of supernovae, those big dramatic explosions marking the end of a star's life. It happens like this. A massive star runs out of fuel, its core collapses, and it blows itself apart. Sometimes a white dwarf star steals too much material from a nearby companion using its super powerful gravity. That stolen gas, mostly hydrogen, spins around the white dwarf in a disk and then slowly falls onto its surface, eventually triggering a massive thermonuclear blast. By the way, since we've mentioned it, a white dwarf is the scorching hot, ultra-dense core that remains after a small or medium-sized star, like our Sun, exhausts its nuclear fuel and blows off its outer layers to form a planetary nebula. Then, over billions of years, it slowly cools and becomes a theoretical black dwarf. It's roughly the size of Earth but packs around the Sun's mass, which makes it incredibly dense. Black dwarfs are powered only by leftover heat, not ongoing fusion. Either way, the birth of a supernova is loud and bright. These explosions often leave behind a neutron star, which is so dense that a single teaspoon of it would weigh about 1 billion tons. Basically, less star and more cosmic anvil. But then there's this rarer kind of VIP event, the kilonova. Astronomers have only ever seen one of those. Back in 2017, one event confirmed what scientists had predicted for decades. Two neutron stars slammed into each other and shook space-time with gravitational waves. Such collisions don't just look cool, they create heavy elements like gold and platinum. Kinda like a cosmic factory. There's a chance that the gold in your phone or on your finger was forged in a violent neutron star crash billions of years ago. Kilonovae have a signature look. The explosion produces so many heavy metals that they block blue light, leaving behind a deep red glow. It's subtle and incredibly hard to catch. Now, here's where things get interesting. What astronomers spotted in 2025 didn't really fit into the supernova box, but it didn't look like a regular kilonova either. It was too powerful and too strange. Neither did it behave the way either event should on its own. That's why some scientists believe they might have spotted something new, a superkilonova. We're talking about a collision or chain reaction so extreme that it goes beyond anything we've observed before. Right now, it's too early to draw conclusions. Astronomers are arguing politely, running more simulations, and waiting to see if the universe decides to do it again. Because in the universe, twice is often the proof. But how could this superkilonova occur? Scientists suggest quite a wild sequence of events. Picture this. A massive star collapses in a supernova, but instead of leaving behind one neutron star, it produces two. Almost immediately, those two ultra-dense remnants begin spiraling toward each other. Within moments, they collide and merge, setting off a kilonova on top of the original explosion. In other words, it could be not just one cosmic blast, but a chain reaction. Two of the most extreme events in the universe happening nearly back to back. The mystery itself started on August 18, 2025, when the LIGO and Virgo gravitational wave detectors picked up a signal from 1.3 billion light-years away. The event immediately caught attention. The ripples in space-time looked exactly like what astronomers would expect from two neutron stars crashing into each other. But there was a plot twist. The International LIGO Virgo Cagra team quickly alerted astronomers worldwide. The data suggested a neutron star merger, but at least one of the objects seemed unusually small. Together, the pair weighed just 0.87 times the mass of the Sun. But neutron stars aren't supposed to be that light. According to everything we know, they should weigh at least 1.2 solar masses. At the same time, the analysis showed a 99% chance that one of the neutron stars fell below that limit. That shouldn't happen under normal conditions. So either the models were missing something, or this object formed in a completely different way. For example, it could be some kind of exotic birth during the collapse of a rapidly spinning, neutron-rich star. So, just a few hours after the alert, the Zwicky Transient Facility at Palomar Observatory spotted something curious. There was a fast-fading red glow coming from the same patch of sky. At first, it seemed that this discovery could solve the puzzle. For the first 3 days, the object behaved exactly like a kilonova. It glowed deep red, which is a sign of freshly forged heavy elements like gold and platinum. Everything matched: the timing, the color, and the gravitational waves. Astronomers thought they were witnessing the second confirmed kilonova ever seen. And that's where things got weird. On day 4, instead of fading away like a kilonova should, the object started getting brighter and bluer. That's like a major red flag in astronomy. Follow-up observations from the Keck Observatory in Hawaii revealed signatures of hydrogen and helium in the light, and those chemical fingerprints do not belong to kilonovae. They belong to supernovae, more specifically, a Type 2b stripped envelope supernova. This kind of explosion happens when a massive star loses most, but not all, of its hydrogen before blowing itself apart. It often happens because a nearby companion star siphons material away. At that point, many astronomers wrote the event off as a normal supernova that just accidentally happened near the gravitational wave signal. After all, regular supernovae don't usually produce detectable gravitational waves, but the timing and the early kilonova-like behavior, plus the strange mass measurements, didn't fit into that explanation. The event started to look like something far stranger. Now, most researchers still admit there's a chance all of this was just bad cosmic timing. Statistically speaking, they can't fully rule out that the neutron-star merger and the explosion just happened to occur near each other by coincidence. Still, the overlap in both time and location looked strange, and they couldn't ignore it. What if both signals came from the same catastrophic event? It would be an extreme scenario involving a rapidly spinning massive star. This star wouldn't collapse into a single dense core. Instead, its breakneck spin would cause the core to split in two, forming a pair of tiny underweight neutron stars. These newborn neutron stars wouldn't last long. Almost right after birth, they would spiral toward each other and collide. That crash would send out gravitational waves and create heavy elements, just like a normal kilonova. But all of this would happen inside a much larger supernova explosion. In other words, it would be a hybrid. One cosmic disaster stacked on top of another. Interestingly, the term superkilonova wasn't actually invented for this discovery. Originally, it described a theoretical event where a massive, fast-spinning star collapses straight into a black hole, surrounded by a huge disk of material. This material is capable of producing giant amounts of heavy elements, possibly several times the mass of the Sun in gold and platinum. The new study suggests using superkilonova to describe a supernova that briefly creates and destroys a pair of neutron stars before anyone notices what really happened. The team is careful not to oversell the idea. After all, the event happened far away. Moreover, the signals overlap in complicated ways, and untangling them perfectly isn't possible with current data. So, coincidence is still on the table. But if superkilonovae turn out to be real, they would help us solve several mysteries at once. For example, they offer a way to form low-mass neutron stars and help explain how the universe's heaviest elements might be created. Future observatories could help us figure out this phenomenon. Upcoming missions like NASA's Nancy Grace Roman Space Telescope and the UVEX satellite will watch the sky, increasing the chances of catching more of these blended explosions. If astronomers start detecting more mergers involving unusually small neutron stars, the case will finally be solved. Until then, the idea of a supernova and a kilonova happening together remains one of the most intriguing what-ifs in modern astronomy.
So astronomers have spotted about a dozen mysterious explosions in space, and no one really knows what they are or why they're happening. At the moment, they occur about 200 million light-years away. But what if, one day, they get much closer to our planet? Now this all started back in 2018. One day, telescopes saw a giant boom far away in space. That explosion was incredibly bright, about 100 times brighter than a normal star explosion, called a supernova. The strange thing was that normal supernovae take weeks or even months to fade away. But that one went from kaboom to poof, gone, in just a few days. It got extremely hot and huge, about the size of our whole solar system, and then vanished like it never happened. Scientists were seriously confused. Now they named the explosion the Cow, because its official name was too long and not exciting at all. Since then, astronomers have been hunting for more of those oddball explosions. And indeed, they've found a few more and given them weird animal names too. That's how we got the koala in 2018, the camel in 2020, the Tasmanian devil in 2022, and the finch or the fawn in 2023. All of those are part of a strange group called LFBOTs. That stands for Luminous Fast Blue Optical Transients. Luminous means they're super bright. Fast because they happen and disappear really quickly. The blue color results from their temperature. They're super hot, like 72,000 degrees Fahrenheit. And optical transients means they show up in visible light and don't stick around for long. Even now, the scientists are still scratching their heads, trying to figure out what's causing these bizarre space flashes. It's like the universe is playing a mysterious game, and no one knows the rules yet. At first, scientists thought those space explosions were failed supernovae. That's when a star tries to explode but instead collapses in on itself, kind of like a balloon popping inward. That collapse can create a black hole in the middle that will eat the star from the inside out. But recently, a new theory has popped up, and it's even cooler and creepier. It has to do with black holes, super squished leftovers from exploded stars. They're so powerful that even light can't escape their clutches if it gets too close. That's why they're totally dark and impossible to see directly. Now, some space scientists think that unknown black holes, not too big and not too small, might be pulling in stars that get too close, which produces those explosions. Such holes are called intermediate mass black holes, and no one has actually seen one of those yet. They're like space's biggest mysteries, and we'll try to solve it in a few minutes. But after that, you need to know that a new LEFBOT has shown up in space. It was spotted by a telescope in Liverpool and is currently called AT2024 WPP. Yep, scientists still haven't picked an animal name, but they're thinking maybe the wasp. What do you think of this name? Share it in the comments. Anyway, one of the scientists is sure that it's the best one since the cow. The most recent space explosion is super interesting and extremely bright, like me. Maybe the brightest one since this whole LEFBOT thing began in 2018. This new WASP boom also doesn't look like a failed supernova. And still, scientists are checking all the data just to be sure. Now, scientists are pretty sure mid-sized black holes that could cause the explosions must exist somewhere. It's like knowing a secret creature might be hiding in space, but no one has gotten a photo of it yet. Some scientists think that this idea is the most exciting, and that it might even help explain dark matter, one of the biggest mysteries in the entire universe. Well, whatever the truth is, a recent discovery might shed light on the existence of mid-sized black holes. The thing is, when it comes to black holes, space has a few different sizes – small, super huge, and something in the middle. The small ones are called stellar mass black holes. They're around 5 to 50 times heavier than our Sun. The giant ones are called supermassive black holes. Makes sense. They're millions or even billions of times heavier than the Sun. They usually hang out in the middle of galaxies. And then there's the mysterious kind in between, called intermediate mass black holes. Those are like the missing link of black holes. Scientists are pretty sure they should exist, but we barely know anything about them, like where they came from, how they grow, or what they're made of. Good news, that mystery might finally be getting solved. Thanks to several new studies, scientists now have some exciting new clues. Researchers have found waves in space, which are called gravitational waves, that seem to come from black holes smashing into each other. And not just any black holes, but ones that are 100 to 300 times heavier than the Sun, which may mean that they're those mysterious mid-sized black holes. Plus, those are the biggest black hole collisions we've ever recorded on Earth. Now, black holes are like space fossils, super old history clues. And those newly discovered black holes could tell us about the first stars that ever lit up the universe. The problem lies in the fact that our tools on Earth, like LIGO, which stands for Laser Interferometer Gravitational Wave Observatory, only catch a tiny moment of these black holes crashing together, literally just a split second. That makes it tough to figure out where those medium-sized black holes come from. So, scientists have a new plan. One scientific lab is getting ready for a future space mission called LISA, short for Laser Interferometer Space Antenna. It's a cool space project by NASA and the European Space Agency, launching in the late 2030s. LISA will float in space and be able to catch the whole story of black hole crashes, not just the final boom. It will track black holes years before they crash into each other. And, if all goes well, we might finally figure out where these mysterious black holes come from and learn even more about how our universe began. So you might be wondering about how LISA will do it. Remember we talked about ripples dashing through space called gravitational waves? Black holes crashing into each other could send them out. Well, LISA is being built to listen for such waves. It'll float in space and look for all kinds of cosmic shakeups, not just huge ones, but also smaller black holes spinning around giant ones. Now, why do gravitational waves matter? A lot of space stuff is too dark to see with regular telescopes, since no light comes from it at all. But gravitational waves don't care about light. They go through everything, telling us about the secrets hiding in the dark parts of the universe. By studying them, scientists hope to learn about things we've never seen before, like black holes, or what really happened at the very start of the universe, and maybe even things we don't know exist yet. LISA will help us figure out how the universe began, how it's changing, and what it's made of. Now, getting back to those black hole collisions, finding them isn't easy. But researchers have come up with a smart solution. They're using artificial intelligence to make sure the signals from space aren't messed up by noise from Earth or the machines themselves. This work was part of a project focused on combining AI with space science. Scientists are getting more confident that intermediate mass black holes, the ones in between small and supermassive, are real. And they might be some of the most exciting things we can study using gravitational waves, both from Earth and from space. So the next big step? Looking to the Moon. Future detectors placed on the lunar surface could be even better at catching certain types of space waves, especially ones that Earth-based machines might miss. That would help scientists figure out where those black holes dwell in space. Besides this research, scientists are also planning human exploration of the Moon. They're helping NASA choose the best spots for future missions, focusing on big science goals like solar physics, space weather, and how the universe works. Right now is a super exciting time, not just for studying black holes, but also for connecting space exploration and science. Now, I don't want to freak you out, but something bizarre has erupted in the depths of space. It was an explosion brighter than billions of suns. But the real mystery is that it doesn't match anything astronomers have ever seen. Usually, cosmic events like this follow familiar patterns, but not this one. It's a cosmic anomaly. This strange cosmic explosion has left astronomers totally baffled. It could be a super rare event where everything lines up just right. Or it could be something completely new, never seen before. This event was first detected by an X-ray space telescope called the Einstein probe on April 8, 2024. It first appeared to be a regular gamma-ray burst. Those typically give off incredibly bright X-rays. But could the answer really be so simple? Something didn't add up. Now, gamma-ray bursts are the most powerful explosions in the universe, and they can happen in unusual ways. Long-duration gamma-ray bursts are caused by the demise of massive stars that spin incredibly quickly. When these stars run out of fuel, their cores collapse under gravity, forming an extremely dense object like a black hole. At the same time, the outer layers of the star are blown away in a massive explosion called a supernova. Gamma-ray bursts are followed by jets. Those are twin beams of material shooting out from opposite sides of the collapsing object. They're super fast, moving at nearly the speed of light. These jets appear brighter if they're pointed directly at us. It's like how a flashlight beam is brightest when it's aimed straight at you rather than at an angle. Now back to our unusual cosmic explosion. Remember me telling you something wasn't adding up? Hey, it was just 45 seconds ago. Well, the problem was that when multiple telescopes observed this event in different wavelengths – ultraviolet, optical, near-infrared, radio, X-rays, gamma rays, you name it – it didn't match any known type of event. The most likely explanation, according to current research, is that this explosion is the result of a white dwarf star being torn apart by a medium-sized black hole. And still, it's not so simple. Now, black holes are areas in space where gravity is so strong that nothing, not even light, can escape. That's why they're called black holes. It's believed that stars with at least 3 times the mass of our Sun can collapse under their own gravity once they run out of their stellar fuel. When a star has so much mass packed into such a small space, its gravity becomes so powerful that it forces everything, including atoms, to squish together. This intense density leads to the formation of a black hole. So, when a white dwarf star is torn apart by a medium-sized black hole, it results in a high-speed jet of material that can be aimed directly at Earth. So, could this space disaster be the reason behind our mysterious event? Unfortunately, even though it ticks some boxes for several types of phenomena, including the one involving a white dwarf, it still doesn't fit all the criteria for any of them. The event's short duration and high luminosity are hard to explain using any scenarios we can produce. So, does it mean we have come across something completely new? The universe is full of energetic flashes caused by outbursts from stars and black holes, supernova explosions, stars being eaten by black holes, and other cosmic events. Astronomers usually figure out what these events are by analyzing their duration, frequency, source, and the specific combination of wavelengths they emit. Here, I just have to say a few words about the instrument that discovered the space anomaly. The Einstein probe is an X-ray space telescope project led by the Chinese Academy of Science in collaboration with the European Space Agency and the Max Planck Institute for Extraterrestrial Physics. That's a mouthful. This project is all about studying high-energy space events over time. Its main goal is to find inactive black holes and figure out how matter falls into them by spotting X-ray flares produced by these sudden space events. The Einstein probe also hopes to catch the electromagnetic signals from events that cause gravitational waves, like when neutron stars merge. It also keeps an eye on the whole sky to spot all kinds of space explosions and track already known changing X-ray sources. After the Einstein probe detected that ultra-bright space flash, the event was also observed by a few other ground-based and space telescopes, including the Nuclear Spectroscopic Telescope Array, SWIFT, Gemini, Keck, Dark Energy Camera, Very Large Array, Australia Telescope Compact Array, and Neutron Star Interior Composition Explorer. That's a bigger mouthful. Using all this data, astronomers pieced together the event's characteristics, but it didn't make the case any clearer. Quite the opposite. It just deepened the mystery. This event flared up in soft X-rays for the first 10 seconds, then plateaued at a steady glow for about 4 days before fading quickly within another day. This is much longer than typical gamma ray bursts, which usually last from a few milliseconds to several hours. But it was still not long enough to fit into other known categories. The event's brightness in X-rays was also unusual. It was too bright for some types of phenomenon, but not bright enough for others. The most puzzling part is that the Very Large Array didn't detect any radio emission from the source when it was observed 11 days, 158 days, and 258 days after the initial flare. Now normally, when something this bright in X-rays lasts for this long, it's usually associated with a luminous radio counterpart. But in this case, no radio signals were detected, which is very strange and adds to the mystery. Astronomers didn't give up and considered several other possibilities, like fast blue optical transients. Those are a new class of explosions that release huge amounts of energy and blast matter into space at incredibly high speeds. These bursts are so powerful that one F-bot can be at least 10 times more powerful than a regular supernova. Fast blue optical transients do look like supernova explosions, but they are much faster. They flare up and fade away much more quickly than regular supernova. They're also much hotter, which makes the light seem bluer compared to other supernova. Since these explosions happen so quickly, it's tough to figure out what causes them. In January 2019, astronomers narrowed it down to 2 causes: a black hole consuming a white dwarf star, or a rare kind of supernova that leads to the formation of a neutron star or a black hole. Now, another explanation for our mysterious space explosion, and astronomers think it's the most likely one, is a tidal disruption event. It happens when a black hole swallows a star, causing a flash of light. When a star gets too close to a supermassive black hole, it doesn't get off easily. No, the black hole's powerful tidal forces tear the star apart, breaking it into pieces and pulling it toward the black hole. Its remains turn into a stream of debris that falls toward the black hole's accretion disk. However, before the debris settles into the disk, it overshoots the black hole in an elliptical path, only to be pulled back in. At one point in this path, the debris collides violently with other parts of the star being pulled in, and that's when we start to see the first bursts of emissions. In some rare cases, tidal disruption events create huge jets of material that shoot out from the black hole's poles. If these jets happen to point directly at Earth, we can see the signature of the event. It often looks like an intermediate mass black hole eating a white dwarf star. However, there should still be some radio emissions coming from the jet of a tidal disruption event. The reason none have been detected yet might be that the event was likely observed too early. Previous studies suggest that it can take hundreds or even thousands of days for the jet material to slow down enough to start sending out radio signals. If future observations pick up radio emissions, it could help solve the mystery. But if there are no signals, it might mean it's a very unusual gamma ray burst or something completely new that we haven't seen before.
All the stars we see, including our Sun, are in a balance of powers. Stars are very heavy objects, so they have strong gravity, which presses them from the outside and makes them shrink. But inside a star, while it burns fuel, there are nuclear reactions that produce incredible amounts of energy. This energy is the light and heat that we feel during the day. But most importantly, these reactions increase the pressure inside the star and create a force that is fighting with gravity. So as long as the star has a full tank, it's safe. But then, the fuel runs out, the pressure inside the star falls, and the gravity wins. A star the size of our Sun can shine for about 10 billion years. Specifically, our lovely Sun is about 4.5 billion years old and has already burned half its fuel. The next stage in a star's life comes when it runs out of juice. Internal pressure drops, but gravity continues to press. At some point, a star simply collapses under its own weight and shrinks to the size of its core at the speed of almost a quarter of the speed of light. In less than half a second, a huge star turns into a small and dense object. This rapid collapse creates incredible shock waves that cause the upper layers of the star to explode. Now, an incredible amount of energy and matter is thrown into outer space. At this moment, luminosity of the star increases millions or even billions of times. This is the flash that our scientists can see with super powerful telescopes. But the light from this explosion doesn't reach our planet until many years later, so in fact, this star has long since faded. There are several options at this point. It all depends on the size of the star. If its mass is small, about the mass of our sun, then for several months, this flash will become brighter and brighter until it reaches its peak. Then, the energy of the explosion will begin to dissipate, gradually fading and cooling down. A few years will pass, and the temperature of the former star will match that of space, and it will simply cease to exist. But the heavier the star, the more interesting the events will be. Heavy stars burn their fuel too quickly and have a much shorter lifespan. Stars weighing about 8 masses of the Sun can collapse into a rather unusual object, which is rarely found in the universe, a neutron star. This dull ball is only 6 to 12 miles wide and covered with a hard metal crust about half a mile thick. Neutron stars can weigh about 2 suns and have a strong gravity force. If you feel comfortable and in good shape on Earth, you wouldn't even be able to lift a needle or a match here. What's more, you would be pressed to the surface like a pancake and just unable to move. But there are stars dozens of times heavier than the Sun. An explosion of such a supernova, which weighs at least 40 times more than the Sun, gives birth to the most inexplicable and mysterious object in the universe, a black hole. At first, an incredibly bright explosion occurs. A shock wave spreads, carrying dust and matter of the former star around like a fog. And at the place of the explosion, only a small black disk is left. This black abyss is the heaviest object in the universe. It's so heavy that its gravity curves space-time around it. Yes, the closer you are to a black hole, the slower time will go for you. If you could get close enough to one of them, spend a couple of minutes in its orbit, and return to Earth, you would simply not recognize your home. 1 minute near a black hole can be a month, a year, or a decade on Earth. This depends on how heavy the black hole is. But don't get too close. The force of its gravity is so strong that even light can't escape from it. Humanity also knows about the existence of supermassive black holes. They gradually build up their mass, feeding on different cosmic objects, just like a predator. Usually, such supermassive black holes lie in the centers of galaxies, and their gravity is so strong they can hold countless stars near them. For example, this is the only photo of a black hole, which is located in the center of the Messier 87 galaxy. The orange glow around it is its event horizon. That's the remains of the light from the objects this black hole has swallowed. You're quite safe though. The closest black hole is 1,120 light-years away. But supernovae can explode not only when gravity wins the fight with the star's internal forces. Sometimes the opposite happens. The nuclear fusion inside the star begins to affect much more matter than normal. The pressure inside a star increases, and it defeats the force of gravity that exerts pressure on the star from outside. At this point, there's a boom! This never happens by itself, and this type of supernova is only possible in binary star systems. 2 stars are spinning around each other. One star begins to swallow the substance from the other. Then the nuclear reactions inside it are no longer in balance, and a supernova explodes. For some time, scientists believed that such an explosion could occur in 2022. There's such a binary system in the Swan constellation at a distance of 1,800 light-years from the Sun. The luminous red nova should have occurred here. Such a red flash would have been visible to the naked eye for months. And after the explosion itself and the merger of two stars, a new, hotter, and heavier star was to appear in their place. But a new analysis of the data revealed a calculation error, and this event will not happen soon after all. So now we see that a supernova explosion is a very dangerous event, and it can cause great harm to our planet if it happens close enough. The main danger is gamma rays. This is the radiation that comes from the explosion. When these rays reach the Earth, they affect our space shield, the atmosphere. They reduce the ozone layer and make us vulnerable to solar radiation and cosmic rays. In this case, all life on the planet is in incredible danger. And the bad news is that such an explosion could happen quite soon. Betelgeuse, the brightest star in the night sky, about 17 times larger than the Sun and 8.5 billion years old. It's begun to exhaust its fuel reserves. Scientists predict that this giant will explode like a supernova at any moment within the next 10,000 years. So it may happen in a few centuries or even tomorrow. Everything will happen as follows. Betelgeuse will collapse in a fraction of a second, and then it will explode so brightly that it will look like a second moon in the night sky. We will observe a new bright spot in the sky for weeks or even months. But then, it will begin to fade until it completely disappears. Not without a trace though. In its place, there will be a neutron star, weighing 1.5 times the Sun. It will be one of the biggest events that humanity has ever seen. Still, we have nothing to be afraid of. Betelgeuse is about 550 light-years away from us, so its X-rays and ultraviolet light will not affect us. A much greater danger is posed by the release of material that occurs in a supernova explosion. But this shouldn't make you worried either. The shock wave won't reach the Earth until 6 million years later, and it will be suppressed by the oncoming solar wind. So if we see Betelgeuse explode today, it will be an epic sight. But in fact, the star will not exist at the time, because it will mean the event itself happened almost 6 centuries ago. It's just that now the light from it has reached us. Some scientists believe that the Ordovician Silurian extinction events, which occurred almost 500 million years ago, happened exactly because of a star explosion. Then, almost 60% of marine vertebrates went extinct. Yet, it was not a supernova, but a hypernova. That is what scientists call explosions of stars 100 to 150 times larger than the Sun. In addition to the abnormal weight, the star must rotate very quickly. Such objects are very rare. In our galaxy, there are few of them, and scientists believe that hypernovae occur about once in 200 million years.
So get this. Earth might be actually located near space highways that could connect us to other worlds. That's because our Sun sits right in the center of a giant bubble filled with hot gas, carved out by ancient supernovae. And this bubble likely has tunnels linking us to distant galaxies. So, does it mean it's time to develop space tourism? Well, let's figure it out. Most of us think space is just planets floating around in eternal darkness. But new research hints at the possibility that it might not be really true. It turns out our whole solar system is actually sitting inside a giant bubble of hot, thin gas. And it gets even better. Scientists now think there might even be a weird cosmic tunnel or channel made of this stuff, It supposedly stretches out toward faraway stars. Astronomers spent years mapping the sky, and after they put all the data together, they found something that looks like a long pathway of hot, low-density plasma, which is basically that very thin, superhot gas. And this so-called channel reaches out from around us to distant constellations. Researchers from Germany confirmed this discovery using data from a space telescope called eRosetta. We'll talk about it a tiny bit later. Now, interestingly, scientists discovered that our solar system sits inside something called the local hot bubble a long time ago. This bubble is actually a huge area, about 1,000 light-years wide. It was created when several stars exploded in giant supernovas millions of years ago. Those explosions heated up the gas around them and basically carved out this bubble of hot, low-density space. And their shock waves created weak points in the bubble around us, eventually forming interstellar tunnels. That cosmic event was so huge that the leftover hot plasma is still floating around us today. Now, to understand this bubble better, scientists used eRosetta, which is an X-ray telescope. It scans the sky looking for soft X-ray light. That's a kind of light we can't see with our eyes. It comes from hot gas, old supernova leftovers, and other structures in space. They also compared eRosetta's new information with older data from another X-ray telescope called ROSAT. And finally, putting all this information together, they were able to make a much clearer map of what's around our solar system. Mind you, this wasn't easy. They had to divide the sky into thousands of tiny pieces and carefully measure faint signals coming from warm gas, empty pockets of dust, and other stuff floating in space. But their effort paid off. After sorting through everything, they managed to figure out the faint glow of hot plasma around us. It proved we were not just drifting through empty space. We're inside a giant burned-out bubble created by extinguished stars. But what really surprised scientists was the discovery of some kind of channel. It looked like a long tunnel in space, cutting through the hot gas around us and connecting our part of the galaxy to star systems far away. They also found signs of another channel pointing toward the Canis Major constellation. And those might not be the only ones. The data suggests there could be a whole network of such paths, branching out through space. Each one works like a hidden back road. Scientists used to guess that the space around our solar system might have little pockets or rooms carved out by old exploding stars. We could probably imagine them like caves inside outer space, but no one had the necessary tools to actually prove it. But now, thanks to that new data from the eRosetta telescope, they finally have a clear picture. The telescope showed that the space around us wasn't just empty. It's full of hot, thin gas and strange shapes, including tunnels and bubbles. This proves at least part of what older scientists predicted. We're living inside a giant bubble of hot gas, and that bubble connects to other bubbles through long, low-density channels. The new study also shows that the pressure inside our bubble is lower than scientists expected. This might mean the bubble isn't closed. It could be open in some directions, letting that hot gas flow out into other parts of space. In short, this hot bubble isn't simple at all. Parts of it might be open pathways, and other parts look blocked off. Being inside it is kind of like trying to walk through a forest. Some areas have clear trails, and others are packed with trees. And even though astronomers have mapped big chunks of the bubble and found these strange channels, there's still a lot they don't fully get. Some paths look like they're made of a bunch of connected empty pockets, and others look totally closed. To understand the whole picture, we'll need better tools and more data. Hopefully, with stronger X-ray telescopes, deeper sky scans, and better computer models, we'll finally understand the nature and structure of the bubble we're living in. We might be able to make a kind of map of those hidden channels and learn how they affect things like cosmic rays, dust, and the solar wind around us. Now, speaking of telescopes, we can't help but mention the one that helped us figure out the very existence of the bubble around us. The thing is, scientists have been trying to understand a faint glow of low-energy X-rays that seem to cover the whole sky. For many years, they weren't sure where this glow was coming from. And then, the NASA-supported DXL mission finally helped to solve the mystery. Researchers used old but reliable detectors that first flew on a rocket in the 1970s. With these instruments, they confirmed that most of this X-ray glow came from a huge area of extremely hot gas around us. It was named the local hot bubble. Back in the 1990s, another X-ray mission called ROSAT made pretty good maps of the sky, and it found something surprising. Comets gave off soft X-rays too. Later, scientists realized this happened when the solar wind, fast particles from the sun, collided with neutral atoms. This process, called charge exchange, can happen almost anywhere in space. Because of this, some scientists started to doubt whether the local hot bubble was really the main source of the X-ray glow. So, to test this, DXL launched on December 12, 2012 from New Mexico. The rocket flew high above Earth's atmosphere for about 5 minutes, giving the instruments a clear view of space. The goal was to look at a worst-case situation where lots of charge exchange might occur. Right now, our solar system is moving through a cloud of cold gas in space, known as the local interstellar cloud. That's also nicknamed the local fluff. Cute, right? Neutral hydrogen and helium atoms from this cloud move through our solar system at very high speeds. Hydrogen gets affected easily by different forces, but helium mostly follows the pull of the sun's gravity. Because of this, the helium forms a focusing cone, a region with extra helium that Earth passes through every December. This cone is the perfect place to look for charge exchange, since it holds more neutral atoms than usual. But what happens during charge exchange? The solar wind comes from the sun's corona, the star's superhot outer layer. The particles in the solar wind have lost many of their electrons. When one of these particles hits a neutral atom, it can steal one of the atom's electrons. The stolen electron briefly gives off a soft X-ray. This is how the glow is created. Now, to compare things, the researchers also looked at old ROSAT data from 1990, taken in a direction away from the helium cone, where charge exchange should be weak. By putting everything together, the scientists found that only about 40% of the soft X-rays come from inside our solar system. The rest, the majority, comes from the local hot bubble. This means the huge cloud of hot gas around us really is the main source of the X-ray glow. But let's get back to the discovery of the Space Intergalactic Tunnel. It's a valuable lesson for us that space might look calm and empty when we look up, but that's not true. Space around us actually contains dust, plasma, radiation, magnetic fields, and mysterious tunnels. All of these things mix and swirl together, making space much more complicated than a simple vacuum.
Let's take a little satellite, tie it to the shuttle with 12 miles of cable, and send it for a spacewalk. It might sound like another crazy plot for a YouTube hit video, but this idea actually belonged to NASA. In 1996, they teamed up with the Italian Space Agency to try one of the boldest, strangest experiments ever attempted in orbit. The mission was called TSS-1R, short for Tethered Satellite System 1R. They came up with a plan to reel a satellite from the Space Shuttle Columbia on a tether that could carry an electric current. As the shuttle zipped around Earth, that long cable would slice through the planet's magnetic field lines. In physics terms, moving a conductor through a magnetic field generates electricity. So, the Space Shuttle Tether Satellite combo was about to turn into a giant orbital power generator. It was like plugging an extension cord into Earth's invisible magnetism. The physics behind this craziness was rock solid. Engineers hoped this tether would pump out usable power, maybe even thousands of volts. If it worked, It could change how spacecraft get electricity or inspire new ways of braking in orbit using electrodynamic drag. So, launch day came. Columbia lifted off. The crew prepared the system, and they started letting the satellite out on its long, long cord. At first, it was smooth sailing. The satellite glided away, the tether unreeled like a spool of cosmic fishing line, and the science team was buzzing with excitement. As the line stretched longer, it started generating more and more electricity, over 3,000 volts at its peak. Everything was running perfectly like a dream experiment. And then, just as the tether was almost fully extended, nearly the full 12 miles, things took a dramatic turn. A localized electrical discharge zapped through the tether's insulation. The cable arced and burned a hole right through itself, and with one fatal snap, the tether broke. Just like that, the grand experiment was toast. The crew could only watch as the little satellite, still trailing its dangling wire, floated off into space like a lost balloon on the world's longest string. Years of hard work preparing the experiment just literally drifted away. Visually, it was almost comical. Reporters couldn't resist calling it the goofiest space experiment in history, and honestly, they weren't wrong. It looked less like cutting-edge space technology and more like someone had tied a toy to a string and let it loose above Earth. But, goofy or not, the experiment actually proved the physics worked. Before the failure, the tether really did generate significant electricity, exactly as the scientists predicted. Over 3,000 volts coursed through that cable before it fried. The idea of using conductive tethers for power and propulsion in space wasn't a fantasy. It was all real. The problem wasn't the science, it was the engineering. Space is an unforgiving place, and one small weakness in insulation was enough to take down the whole mission. Even though TSS-1R ended with a literal snap, it left behind valuable data. Engineers learned more about how tether systems behave in orbit, and the concept is still alive today. Researchers keep looking at space tethers for everything from satellite deorbiting systems to futuristic power stations in orbit. So that broken cable might have been a letdown in 1996, but it wasn't the end of the story. If a satellite on a cable isn't wild enough for you, how about two golden orb weaver spiders on the International Space Station? In 2011, NASA sent these two cuties, called Gladys and Esmeralda, up there on Shuttle Endeavour, just to see, can spiders spin webs in microgravity? Turns out, yes. The experiment lasted 45 days. While floating in orbit, the spiders went ahead and spun webs, but the webs looked shockingly symmetrical, perfect circles, rather than the slightly lopsided webs they usually make on Earth. The spiders, deprived of down and up, used light inside their habitat to orient themselves. On Earth, spiders use gravity to guide how they stretch their legs and spin out their web lines. But in space, with no gravity to rely on, they looked at the lamps and used that as their ground. But that experiment in 2011 wasn't the first space adventure for spidernauts. Way back in 1973, NASA launched two female European garden spiders called Arabella and Anita into space aboard Skylab 3. The idea of this experiment actually came from a 17-year-old high school student in Massachusetts. The spiders were stashed in little containers and then coaxed into a special tank to spin webs while orbiting Earth. At first, Arabella struggled. She took a while to adapt, and the first web she spun was incomplete. But by the next day, she managed to finish it. Over time, the webs she produced were finer and more delicate than normal Earth versions, and scientists noticed subtle differences in thickness across the threads. But NASA wasn't just curious about spiders for the sake of, spiders. Scientists wanted to figure out how near microgravity messes with the central nervous system. Not just in spiders, but in animals in general, humans included. Spiders actually make the perfect test subjects because their webs are basically brain maps in silk. You can tell how well the spider's nervous system is working just by looking at the shape and quality of the web it spins. On Earth, a spider has a whole toolkit. It knows how heavy it is, so it figures out how thick the silk needs to be. It uses wind and gravity to decide where to anchor and how to stretch the lines. But the way spiders adjusted to build webs in zero-G gave clues about how our own motor systems and brains might behave if we had to live long-term in space. Sadly, Arabella and Anita, the first two spidernauts, did their job, spun webs, gave us tons of data, but didn't survive their mission. The likely cause was dehydration. On a brighter note, scientists have grown everything from lettuce to yeast on the ISS. But one of the oddest was trying to see if fungus could shield astronauts from radiation. They took samples of a fungus that thrives in places with high radiation and monitored how it reduced radiation passing through it. Over a thin layer of this fungal mat, radiation levels dropped by about 2.17% compared to a control sample. At the same time, the fungus had around a 21% growth boost in microgravity. So not only did it block some radiation, it actually seemed to use radiation to fuel itself, almost like a weird fungal solar panel. Now, you might ask, why fungi? Why not steel or lead? Because living things self-repair, self-replicate, and adapt. If you could grow stuff that helps shield you from radiation while it's doing other jobs like repairing and evolving, that's gold for long space missions. The idea is, maybe astronauts could grow part of their radiation shield using organisms, instead of hauling tons of heavy shielding materials into space. There was also broader research catalogs on space fungi and microbes. One study in 2019 cataloged all the bacteria and fungi found inside the ISS, on walls, equipment, windows, sleep stations, you name it. They found the fungal communities were pretty stable over time. That means fungi are not just surviving, but persisting in that closed, harsh space environment. This science experiment is like a hint that we could have a future where biology and engineering mash together. If we can harness fungi or other organisms as part of a spacecraft structure, we open up a whole new way of designing space habitats. Instead of walls you build once, you could have walls that grow. To make radiation levels Earth-like on Mars, you might need a 7.5-foot thick layer of this fungus covering a habitat. That's huge, but maybe easier than dragging tons of lead through space. There's a lot to figure out about safety, control, dose limits, and how this would work long-term. But in the future, astronauts might live behind walls of living mushroom shields, literally harnessing biology to survive the void. A giant wormhole, or simply said, a connection between regions of space-time, opens up in space near Earth. Our world faces chaos unlike anything before. Satellites incinerated, skies ripped open by radiation storms, entire power grids blacked out. The atmosphere is swelling and scorching, the oceans are boiling, the magnetic shield is shattering. Suddenly, the wormhole destabilizes. Space-time starts to unravel, tearing Earth apart from the inside out. People are seeking shelter, but nothing can save them anymore. Look at this devastation. This isn't just a sci-fi scenario. It's a cosmic apocalypse waiting to happen and rewrite the fate of humanity. The thing is, some black holes might actually be secret space portals. It may sound like something straight out of Stranger Things, but it's not. Scientists have been wondering for years if some black holes could actually be wormholes in disguise, tunnels through space and time. And now, a new study says this might actually be possible, at least in theory. Wormholes are like cosmic shortcuts that let you pop out in a totally different part of the universe. Unfortunately, we've never found one, and the whole concept still lives in the land of what if. Here's the problem. To actually make a wormhole work, you need something called negative energy. That's not just rare. It doesn't even exist in the regular universe. Maybe in some weird world of quantum physics, but even there, it's super uncertain. Still, scientists have a wild thought. What if some black holes aren't just giant space vacuums that swallow everything around them, but are really hidden wormholes, The odds of that are tiny, like winning the lottery while getting struck by lightning and discovering extraterrestrials at the same time. But mathematically, it's not impossible. That's where the new study comes in. Researchers looked at a weird type of black hole called a Schwarzschild black hole. These ones don't spin, don't have electric charge, and, very predictably, are totally hypothetical. They're just the math version of a black hole, not something we've seen in space. In any case, the team studied something called quasi-normal modes, which is just a fancy way of saying how space vibrates around a black hole when you mess with it. These vibrations don't go on forever. They fade out like the ringing sound you get when you hit a bell. By analyzing those space-time vibes, scientists tried to figure out if they could tell the difference between a regular black hole and a wormhole pretending to be one. It turns out that it's super hard to tell this difference. But maybe that's the point. Wormholes might be hiding in plain sight, wearing black hole costumes like it's space Halloween. Wormholes could copy a black hole's behavior almost perfectly, at least on paper. The researchers uploaded the whole study to Arxiv, which is where science nerds drop their ideas before they hit the big journals, and it's already been published in Physical Review D, which is a serious physics magazine. The coolest thing, though, is that it isn't a brand new idea. Scientists have been debating this whole black hole or wormhole thing for decades. Back in 2021, some researchers wondered if the giant black holes at the centers of galaxies, called active galactic nuclei, were actually wormhole entrances. And in 2022, a team in Bulgaria said that the light coming from a wormhole could look almost exactly like what comes from a black hole. There's also this sci-fi level theory that some black holes might be paired with opposite twins, called white holes. A white hole basically spits stuff out instead of sucking it in. Together, a black and a white hole could form a wormhole tunnel. But no one's found a white hole either yet, so that idea is still just theory. By the way, in this latest study, the authors have shown that wormholes and black holes not only look similar, but also sound similar, at least in how space-time shakes around them when they get hit with something. So our next move should be fine-tuning our scientific models, especially near the part of the wormhole called the throat. Scientists want to see if wormholes could fake even more black hole-like behavior, but it's tricky. Some of the math gets super hard. In any case, how about finding out more about these mysterious wormholes? You've seen them in every second sci-fi movie, magical space tunnels that let you skip across the universe. Einstein was the first one to have dreamed them up. Wormholes are still 100% hypothetical, and we've never spotted one. But that doesn't stop people from theorizing. Like, what if a wormhole started sucking in matter like a black hole does? If a wormhole started eating stuff like dust, gas, or space debris, it would create a plasma tornado, a literal space firestorm in its throat. And this twisty storm would eventually blast out the other side of the wormhole, firing hot plasma at nearly 125 million miles per hour. That's about 1/5 the speed of light. It would also be insanely hot in there, so hot it could probably trigger nuclear fusion. Of course, all of this is still just theoretical. No one's seen a wormhole do this. No one's seen a wormhole do anything, actually. But the math says it could happen, if we ever find a wormhole. The bright side of it all is that we would probably spot an event with so much drama. Even though wormholes don't have an event horizon, aka the point of no return, like black holes, they still bend light. Normally, you might not be able to see something like that, but this thing is so absurdly bright from the plasma firestorm that you would actually see it glowing in space. Think of it like a black hole, but with a glowing center instead of just darkness, and a jet of flaming plasma shooting out one side like a broken space faucet. Still, don't get your hopes up for spotting one anytime soon. Even if we did find a wormhole, it probably wouldn't last long. It could break apart or transform into a completely different type of space-time before we even realized what we were looking at. Plus, keep in mind that wormholes might look almost exactly like black holes unless you know what kind of light polarization, how light waves line up, to look for. Now let's talk a bit more about black holes themselves. You're likely to know them as insane space beasts that suck up everything nearby – gas, dust, even light. And once something crosses a black hole's event horizon, it's trapped forever. Scientists say that inside, everything gets crushed into a tiny point called a singularity, where the usual rules of physics totally break down. But back in 2010, a physicist named Nikodem Pavlovsky had a crazy idea. What if black holes don't have singularities? Instead, what if the center of a black hole is actually a doorway to another universe? Maybe our entire universe was born from matter shooting out of a black hole in some parent universe. Pavlovsky's theory uses something called torsion, which is like a weird gravitational twist that stops matter from getting crushed infinitely. Because of torsion, instead of crashing into a singularity, matter inside a black hole can create a tunnel, a so-called Einstein-Rosen bridge, or simply a wormhole, connecting a black hole to a white hole. So, imagine matter falling into a black hole in one universe, then popping out of a white hole in another. Pavlovsky thinks this could explain the Big Bang, but as a big bounce, meaning the universe keeps cycling through phases of expansion and contraction, not just one huge explosion. Sadly, if such a tunnel existed, it would be a one-way trip. Nothing would come back through to the original universe. Some scientists are still skeptical because torsion hasn't been proven yet, but other experts think Pavlovsky's model is super promising. They even go further and say that our whole universe might be living inside a giant black hole hundreds of billions of light years wide. Now, we just need to figure out how to test this. Future space studies might give us more clues, like checking if our universe is closed, which basically means that it's curved, without an edge, or digging deeper into cosmic background radiation, which is the leftover glow from the Big Bang. A huge invisible danger zone is hanging above Earth, messing with satellites, zapping electronics, and giving astronauts a headache. Scientists call it the South Atlantic anomaly, and it's kind of like the Bermuda Triangle of space, because weird stuff happens there and nobody fully understands why. Want to know more about this thing? Well, Earth has a magnetic field that protects us from dangerous radiation from the sun. We'll talk about it later. And over one spot on the planet, right above the South Atlantic Ocean, that shield gets weirdly weak. It stretches over South America and parts of Africa, creating a sort of magnetic soft spot. That weak spot is bad news for anything flying up there. When satellites travel through it, their systems can freak out. Computers freeze, data gets scrambled, and sometimes entire instruments shut down. Basically, the space version of your phone glitching out right when you need it most. Astronauts have to be extra careful in this region too. When the International Space Station passes through the anomaly, radiation levels spike. It's not enough to fry anyone, but it's surely not fun. The equipment can take a serious hit. No one knows exactly what's going on yet, but scientists think the SAA might be a clue that Earth's magnetic field is shifting. If that's true, it could mean big changes for the future, for us all. You see, the South Atlantic anomaly is connected to Earth's molten insides. Deep beneath the surface, the planet's core and mantle are constantly moving, flowing, and clashing. The outer core is a swirling ocean of liquid metal, and the mantle above is hot, solid rock. Under Africa, there's nothing to cool things down. The mantle is hotter than usual, which creates certain instability in the magnetic field above. As for South America, there, the Nazca Plate is dragging rock and debris down toward the core. This cools things off and keeps the field more stable. Such a wild temperature difference seems to be fueling the anomaly. According to some sources, it drives it across the Atlantic. The anomaly is slowly drifting westward. The thing is, Earth's magnetic field protects us from dangerous radiation from space, powerful solar winds, and wild swings in temperature, and keeps our atmosphere in check. But over millions of years, the magnetic poles have flipped. When it happens, north becomes south, south becomes north, and during those flips, the field can weaken. And some scientists thought the South Atlantic anomaly might be a warning sign before a full magnetic reversal. It could mean disaster to humans, but we'll talk about it later. The good news is, these flips take over. On average, Earth flips its magnetic poles about 2 times per million years. That means the next reversal could be hundreds of thousands of years away. Nearly 600 million years ago, our planet's shield almost failed, but at that time, it could have been a good thing. Scientists think this near collapse might have triggered a massive evolutionary boost and helped the first complex life forms to evolve. Back then, during a period called the Ediacaran, the magnetic field weakened drastically and stayed that weak for about 26 million years. With less protection, solar radiation removed lighter gases from the atmosphere, leaving oxygen floating freely in the air and oceans. That oxygen helped the first multicellular oxygen-breathing organisms to see the light of day. Those were strange, squishy creatures that hardly resembled animals today. Some were disc-shaped blobs, fronds, or shapeless fans, stretching over 3 feet long. By the way, one of the earliest known animals, Dickinsonia, was among them. It looks kinda pretty, doesn't it? Now, how do we know all this? Thanks to rocks. They're like time capsules. Tiny crystals inside them preserve the power of the magnetic field from hundreds of thousands of years ago. For example, certain crystals from southern Brazil revealed that 591 million years ago, Earth's magnetic field was 30 times weaker than it is now. And rocks from South Africa dating back 2 billion years showed that the field was at full strength back then. Now, let's explore a bit. Deep beneath our feet, there's Earth's inner core. We're used to thinking about it as a perfect solid ball, but new research suggests it might be changing shape. Over the past 20 years, parts of the inner core may have bulged or dipped by more than 300 feet. That's like a skyscraper popping up or sinking deep underground inside the planet. This core spins independently from the outer liquid core, which creates the magnetic field that shields us from dangerous solar radiation. The magnetosphere is non-negotiable. Without it, Earth would lose its atmosphere over time. Water would vanish, and life as we know it wouldn't survive. It basically keeps the planet alive. Without it, Earth could turn into a barren Mars, which lost its magnetic field billions of years ago, and along with it, almost all its atmosphere. So why is our planet's inner core deforming? It seems to happen where the solid inner core meets the super hot liquid outer core. The molten metal flows around it, and combined with the tug of an uneven gravity field, likely warps its edges. Scientists can't drill down to the core to check this theory. It's 3,200 miles below the surface. But they can track seismic waves from earthquakes as they ripple through Earth. They measure how these shock waves bend, slow down, or speed up, and it can help figure out what the inner core is made of and how it moves. That's probably how they know that the solid inner core is slowly growing, freezing layer by layer of the liquid outer core. But don't worry, it'll take billions of years to fully solidify. By that point, life on Earth would probably already be gone anyway. The sun's gonna swallow our planet long before the inner core stops moving. But let's get back to the topic that, I bet, worries you most. What if Earth's magnetic field just vanished one day? Well, the planet would be hit by a storm of charged particles from the sun. Satellites would start glitching and power grids would go down. We would get zapped with higher levels of UV radiation, the kind that can cause all kinds of serious health issues. In short, it wouldn't be instant doom, but life would get a lot trickier. Luckily, now we know that a magnetic field doesn't just vanish overnight, but ours has been slowly weakening for over a century. So what would life on a planet with a super weak magnetic field look like? You would just have to throw away your compass. It wouldn't point north anymore, just towards the nearest patch of strongest magnetism, wherever that may be. The northern and southern lights would go insane, appearing closer to the equator, all because charged solar particles would be able to get through the atmosphere more easily. Satellites would be under constant attack. Solar particles would fry their electronics, mess with memory, and cause what scientists call single-event upsets. High-frequency radio signals would also get scrambled, thanks to free electrons in the ionosphere. Over time, the solar wind could even start wearing down the ozone layer, leaving us all more exposed to UV radiation. Now, let's decrease the level of drama. A magnetic field isn't the only thing keeping a planet alive. Mars did lose its magnetic shield about 4 billion years ago, and most of its atmosphere got blown away. But Venus has no global magnetic field, but still has a thick atmosphere. If Earth lost its magnetic field completely, we wouldn't instantly vanish, but life would definitely change, and we would have to get used to these drastic changes.
So this thing, Cosmos 482, a high-tech capsule, was built to survive even the most extreme heat of another planet. But something went wrong. It never made it out of Earth's orbit. For over 50 years, it drifted silently around the planet, forgotten until now. In May 2025, gravity finally pulled it down. It's coming home, built to survive re-entry and unpredictable enough to crash anywhere. No warning, no parachute. Just a 1,000-pound sphere falling from the sky, a human-made meteorite capable of causing chaos. In 1972, this funny-looking ball was sent on a Venus-bound mission. Now, Venus is like Earth's evil twin. It's similar in size, but that's where the similarity ends. It's the hottest planet in the solar system, where temperatures reach 860 degrees Fahrenheit, hot enough to melt lead. Atmospheric pressure is about 93 times greater than Earth's, which is like being 3,000 feet underwater and you feel like you're in a trash compactor. And the atmosphere itself is made of carbon dioxide, with clouds that literally rain sulfuric acid. So yeah, it's pretty bad. Yet Cosmos 482 was fully expected to reach it and land. Not for long though. A type of self-destruct scouting mission. The spacecraft was designed to land and transmit data, hopefully for at least a few minutes, on the surface that crushes, bakes, and basically dissolves anything that touches it. How? Well, it came with heat shields for the fiery plunge, a mini AC to cool just long enough, and armor tough enough to handle Venus's brutal environment. It was truly a high-tech reinforced vault built for a one-way trip. And this was in the early 70s, mind you. Fun fact, even today, we've never built anything that could survive that kind of environment. We have deep-sea submersibles that can handle big-time pressure, but not the heat. There are space capsules that can withstand extreme temperatures, but only for a few minutes. Even nuclear reactor walls, designed to handle serious pressure, would crumble if acid rained on them nonstop. Now, a funny twist to this story is that landing on Venus was already achieved in 1970. Venera 7 became the first spacecraft to land on another planet and transmit data back to Earth, surviving on Venus's surface for a full 23 minutes before melting down. It proved the impossible was possible, just not for Cosmos 482. So, what went wrong with Cosmos 482? We've always imagined space travel as firing up the spaceship, launching it, and that's it. However, that's not how it works. First, with an initial boost, you park it in Earth's orbit, like pulling into space's driveway. Then comes a second burn, a precisely timed engine firing that pushes the spacecraft out of orbit and toward its destination. Cosmos 482 made it to the parking orbit just fine, but something went wrong with the second push. No push means no trip, so instead of heading to Venus, it got stuck circling Earth for the next 50 years. But why does something get stuck orbiting for so long? Well, when something gets launched into space, it's not just going up, it's also going really fast sideways. If you throw a baseball up hard enough, it'll eventually hit the ground. But if you could throw it fast enough and Earth wasn't in the way, it would just keep falling around the planet. That's what orbiting means, falling but never hitting the ground. The object's forward speed balances perfectly with the gravity pulling it down. So, to leave Earth, a spacecraft needs to pass through 3 layers. The first is low Earth orbit, or LEO, a few hundred miles up. Here is where satellites, the space station, and tons of leftover junk circle the planet. Cosmos never made it past this point. If the second launch had been successful, it would have gone through medium Earth orbit, where GPS satellites cruise. Then, way out at 22,000 miles, there's geostationary orbit, the sweet spot for weather reports and TV. So now we know how Cosmos ended up there and why it was orbiting for so long in LEO. But what made it suddenly change its mind and fall back? Even in LEO, space isn't completely empty. There's still a tiny bit of atmosphere up there, and over time, it acts like a brake, slowing things down just enough. Think back to that baseball you threw sideways fast enough to orbit Earth. Eventually, it will slow down to the point where gravity takes over. However, Earth is securely protected by its atmosphere. As objects fall back to Earth, their speed keeps increasing up to tens of thousands of miles per hour. When you're moving that fast, the air pushes back really hard. That push creates friction, and friction creates heat, a lot of it. The surface of falling objects can reach over 3,000 degrees Fahrenheit, causing them to melt, shatter, or vaporize completely before they ever hit the ground. That's why scientists don't lose sleep over small debris. Small pieces of old satellites, even tools lost during spacewalks, fall all the time. But they burn up like shooting stars. We just never notice them. Now, a baseball would disintegrate instantly. But what about a giant ball designed to withstand landing on Venus? Thankfully, this potentially horrifying story is anticlimactic, because Cosmos crashed into the Indian Ocean west of Jakarta on May 10, 2025. Radar picked it up streaking through the sky, glowing, breaking, heating up, but still intact enough to make it all the way down. And it did, thankfully, not somewhere crowded. However, now that it's lost beneath the waves, we are free to speculate. How real was the danger? Could it have fallen into a crowded area? Absolutely. If that 1,000-pound capsule had come down over a city, it could have smashed through rooftops, wrecked cars, or worse, seriously injured someone. And no, there wouldn't have been sirens or alerts. Cosmos 482 was launched in the 1970s, long before GPS or live tracking, so there was no signal to follow, no proper guidance system. Scientists could only make rough estimates about where it might land, so if it had come down over land, it would have looked like a meteor. Well, the story of Cosmos, with the K, had a happy ending. But it's not the only thing up there that could fall down. As of early 2025, about 11,700 satellites are active. But with roughly 14,900 in orbit, that means over 3,000 are no longer operational. And the space junk keeps piling up. Space tracking systems monitor more than 40,000 objects that are bigger than a softball, such as pieces of old satellites and bits of rockets. Scientists estimate there are over 1 million fragments larger than a half an inch, and more than 100 million smaller bits still floating around. These can't hurt us down on Earth, but most of it clutters LEO, where collisions can generate explosive clouds of debris, damaging satellites and space stations. Just one crash can trigger a chain reaction called Kessler syndrome, where each impact creates more debris, leading to more collisions until Earth's orbit turns into a demolition derby. Remember the movie Gravity? Yeah, like that. And yes, bigger things from LEO do fall. Cosmos 482 wasn't the first space object to come crashing back. In 2016, Tiangong-1 space station lost contact and tumbled back to Earth 2 years later, eventually burning up over the Pacific. In 2001, the famous Mir station was intentionally brought down. And before that, in 1991, Salyut 7, another space station, unexpectedly deorbited. The 40-ton station broke up on re-entry, and parts that survived scattered over Argentina. Among others, in 1979, NASA's Skylab, the very first American space station, fell back to Earth with only partial control. Pieces of it rained down across Western Australia. Some newspapers even offered cash rewards to anyone who found a chunk. So, we've seen this happen before. Cosmos was just the latest reminder. But NASA and other space agencies do think about this problem. And most modern spacecraft designed to return have parachutes, heat shields, and built-in safety systems to guide them home. But not working satellites and old junk. Yeah, they're still up there. So next time, a space object might not land safely in the ocean. It might crash through your roof while you're watching a BrightSide video. But don't worry,